Yesterday we had, if we had two parallel lines and they were cut by a transversal, then we had some angle relationships. Today we have, if we have two lines and they're cut by a transversal and the angled relationships are correct, that means the lines are parallel. Okay, so yesterday, parallel lines equals congruent angles. Today, congruent angles equals parallel lines. So it's just backwards, but it's the same relationships. So if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So we have two lines. We don't know if they're parallel or not. We get the transversal. And then if we have a situation where this angle is the same as this angle is the same as this angle is the same as this one, and this one is the same as this one, then let's call that M and N. M is parallel to N. So before we had, if you had the lines are parallel, then the angles are congruent. Now we have, if the angles are congruent, then the lines are parallel. So really nothing's different. We have two lines cut by a transversal. If alternate interior angles are congruent, then the lines are parallel. We have two lines cut by a transversal. If the alternate exterior angles are congruent, then the lines are parallel. This one says if two lines are cut by a transversal and the same side interior angles are supplementary, so if blue and red add up to 180, then the lines are parallel. Then we have this new one that's not exactly like the other ones, but kind of makes sense. If I have two lines, and I come in here with a third line and they're perpendicular, and both of them are perpendicular, then the lines are parallel. And it makes sense because this would be corresponding angles that were congruent. So it's kind of the same idea, except just that they're 90-degree angles. And then two lines that are parallel to a third line are parallel to each other. So if I have three lines, N, M, and O, if N is parallel to O and M is also parallel to O, then N is parallel to M. Basically, a bunch of lines that are parallel to each other are all parallel to each other. Yes, exactly, except they're parallel this time. These are just like the ones we were doing before, except instead of saying these lines are parallel, so let's find X, we're saying let's find X that will make these lines parallel. But it's the same math. I go through and I make my checkerboard. And I want to find the X that will make these parallel. That means 1 and 2 have to add up to 180 because they're two different colors. So I have 3x plus 5 plus 2x plus 15 equals 180. So 5x plus 20 equals 180. Subtract 20. 5x equals 160. Divide by 5, and x equals 32. So 32 is the x that you have to put in order for those lines to be parallel. So again, same idea. We've got alternating angles. So red equals red, blue equals blue, red plus blue equals 180. So I have 2 and 8. They're both blue. So 3x minus 4 will equal 2x plus 1. And if I subtract 2x from both sides, I get x minus 4 is equal to 1. And then if I add 4 to both sides, I get x is equal to 5. 3 and 6 add up to 180, so 5x plus 10 plus 120 equals 180, so 5x plus 130 equals 180, so 5x equals 50, so x equals 10. This one you should already be familiar with. The theorem, the sum of the measures of the angles in a triangle is 180 degrees. Everybody clear on that? Triangles add up to 180? Okay, I thought so. So if we have a triangle and it has these kind of marks like this, angles with the same number of little loops in them are the same measure. So that's telling me that if this is x, then this is also x. And if the whole triangle adds up to 180, I have x plus 40 is equal to 180. So 2x is plus 40 is equal to 180. Take 40 away from both sides. 2x is equal to 140. Divide by 2, and x is equal to 70. The other way you can do this, if you don't want to throw the algebra in there, you can see that you have two angles that are the same. The whole triangle is 180, so I can take the 180, I can take away the 40, and that gives me 140 left to be split between two angles, so there's 70 each. Any questions? Okay, triangles add up to 180. Congruent angles are marked. I have 54, 61, and x. So to find x, I take away the 54 and the 61. Did I? I sure did. So 180 minus 54 minus 61 leaves me with 65 degrees. Not too bad. B, I have three angles that are the same. The whole thing is 180. I divide it by 3. They're each 60. Not too bad. C, a little different. I have exterior angles, not the inside angles. So I know that inside the triangle is 180, but I don't know what these two are. So I have to find those first. So this angle is going to be 180 minus 109 because they make a straight line. And a straight line is 180 degrees. So that's going to be 80 minus 9, so 71. This angle is 180 minus 117. So that's 80 minus 10 is 70 minus 7 is 63. Yep. And that'll give you x. So 180 minus 63 minus 71 is 46. Not too bad? And then D, we're back to the same thing as A. So I take my 180, I take away 121, and I take away 29. And I get 30. Sometimes we have triangles that are compound triangles, and they're triangles on top of triangles. I have a yellow triangle. Oops. Yeah, of course. Can't seem to draw on this line, but I have a yellow triangle and I have a green triangle. As you can see, X is only in the yellow triangle, so I'm only concerned with the yellow triangle. So sometimes it's helpful to kind of redraw that, except in a way that works. So that's 90 degrees. This is 26 degrees, and over here I have part that's 32 and part that's x. So I have to try to find the x. So 180 minus my 90 minus my 26 minus my 32, and that'll give me x. So 90 minus 26 minus 32. is 32.